अरे Hello all, very good evening. I welcome you all to day 4 of the bootcamp for Project Build-A-Thon. So yesterday we completed supervised machine learning regression algorithms. I hope all the regression algorithms that we have learned are clear. I hope I'm clearly audible. Can I get a quick confirmation? Okay. So let us quickly begin with today's agenda. So for today, our topic is supervised machine learning classification algorithm. So we are let us see our agenda for today's session. So in today's session, we'll be learning about supervised machine learning classification algorithm. In the classification, we'll be doing three algorithms, that is logistic regression, decision tree classification, and random forest classification. Also, we'll be learning about the evaluation metrics for classification algorithm. Then we have supervised, unsupervised machine learning algorithm, that is k-means clustering. So we will be going through the concept of k-means clustering. So I hope the agenda for today's session is clear. I hope I'm clearly audible. Okay. So now let us begin with our first topic for today, that is supervised machine learning classification algorithm. Before moving on to the algorithms, let us first see what is classification. We all are familiar with what is classification, as we have done in the two introductory sessions. We have learned about classification. So let us just brush up the concept of classification. So classification is a technique where we categorize data into given number of classes. The main goal of classification is to identify the category or class to which a new data will fall. Basically, when in our data, we have target variable as categorical. When we have classes in our target variable, when we have classes to predict, then we use classification algorithms. So the first classification algorithm we are going to do is logistic regression. So logistic regression is a machine learning algorithm which is used for the classification problem. It is a predictive analysis algorithm and based on the concept of probability. So logistic regression is a classification algorithm that models the probability of the output class. Logistic regression estimates the relationship between dependent and one or more independent variables, where the dependent variable, that is our target variable, is categorical. Logistic regression, if I want to summarize, is nothing but applying a sigmoidal function on the output of linear regression which will convert the predicted value into a value between 0 to 1. Then taking 0.5 as a threshold, and if the output is less than 0.5, then it is class 0, otherwise it is class 1. So what I have just said, I would like to explain this mathematically or graphically. So let us see that. So to present that example, I have to open my Word document. I hope my Word document is visible. I hope my Word document is visible. So here, I'm taking an example. X is equals to 35, 45, 55. So these are the value in X. And then I have the value of Y. So this is the data to predict whether the person is obese or not. So here 0 means the person is not obese and 1 means the person is obese, and X is the weight of the person, assuming that the height of all these persons is same. So here if the weight is 35, then the person is not obese. If it is 45, the person is not obese. If it is 55, the person is not obese. If it is 60, the person is obese. If it is 55, the person is not obese. 75 obese, 80 obese, 85 80, obese, 90 obese. So let us draw a graph for so here I am drawing the graph. So I am starting from 35 here. So here I am giving 35, 45, 55, 65, 75, 85, 95. Okay. So now we have the values 0. Here it is 0. This is 0. And here we have the value as 1 on y-axis. This is 65. I have taken the gap of 10, 10. Okay. So if the weight is 35, then value of y, that means the person is, let me take another marker. That means the person is not obese. If it is 45, the person is not obese. If it is 55, the person is not obese. If it is 60, 60 is somewhat here in the middle of 55 and 60, then the person is obese. Again, it is 55, then the person is not obese. If it is 75, then the person is obese. 80, the person is obese. 85, the person is obese. And 90, the person is obese. Okay. So if I draw a linear line here, so it will come something like this. Sorry, the line is not straight. It will come something like this, right? So here, if I'm taking the threshold value as 0.5, 0.5. So below this value, all are considered to be not obese, and above this threshold value, all are considered to be obese. Okay. So if these are the points, then it is fine. If these are the points, then it is fine. But what if I have changed my points? What if I change my points to after 45 we give it as 100, then we give it as 120, then we give it as 55, 75, 85, 90, and then 150. Okay, if these are my points, then only this will be 1, the person will be obese, 1, 1, 1, 1, and 1. Okay, so if my data is something like this, so here I am just putting a point 150 here. 150 will somewhat far, but I am putting it here 150 because I do not have the space to plot it now. Okay, if I am putting 150 here and now my points become now my points have become 35, not obese, 45, not obese, 100 would be somewhat after 95, so it is obese, 120 will be here, obese, then we have 55, not obese, 75, obese, sorry, 75 is obese, 80, obese, 85, obese, 90, obese. Okay, we have data points like this. Now, if I plot the graph, linear line, So I will get the line like this. My line will shift somewhat towards right. Okay. So now if the threshold value is this. Okay. So here all the points less than this threshold will be zeros, and above this all the points will be ones. So here if you see that this point 65 is not obese here, but originally it is obese. According to the data, it is obese. So what happens here is if we put a linear line on a data like this, then we get issues of misclassification. Then we get an issue of misclassification. Okay. So when we have, so what happened when it will be misclassified? Then the predictions will not be accurate. So here we cannot simply use linear line. Here we cannot simply use linear line. So here what we will do, we will scale our data within a range. We will scale our data within a range. So this is why we applying standard scaling. We apply standard scaling when we do classification to scale our data into a single range to avoid misclassification. So if you all understood this concept, so now understanding this logistic regression will become easier. So here I have this data. So if weight is this, then the person is obese. If weight is that, then the person is not obese. So this is how we will plot a linear line. This is how we can plot a linear line here. But what about all the points below 0 and what about all the points above 1? These are all points here. These all points here will be considered as one only. Will be considered as one only. Right? This point will be considered as 1. This point will be considered as 1. All the points above this point will be considered as 1 only. And all the points below this 0 point will be considered as zeros only. Okay. So what we do, we just simply transform our data in such a way that all the points above 1 will become 1 and all the points below 0 will become 0. Then our data will become something like this, this and this. Okay. So what we did, we scaled our values within the range of 0 and 1. So if we are getting any value above than 1, it is considered to be 1, and any value less than 0 will be considered as 0. So we are scaling our values between the range of 0 and 1. So logistic regression equation is derived from the equation of straight line. For example, this is my equation of the straight line. This is the equation of the straight line. We all are aware of this equation. So we have seen this equation in multilinear regression, right? So this is our equation. Now we will apply some function on it so that we can transform it into this data. Okay, like so that we can transform it into this data, this shape. Okay, how do we do that? We apply sigmoid function on the equation of straight line. We apply sigmoid function on the equation of straight line. So what happened is, I have the equation of straight line y is equals to mx plus c. Okay. Now I have this sigmoid function. I have this sigmoid function. I will apply sigmoid function on it. So this is when I apply sigmoid function. Okay. When I applied the sigmoid function, I got this value. So y is equals to this value. Y is equals to this value. So I will replace y with this. I can replace y with this. So let us replace y with this value. Right. So now to eliminate this, we have to apply log on both sides, some mathematics. So apply log. So this will become okay. So now this is how we apply the sigmoid function. So let us see here. Here we have done the same. We have taken we have taken uh, multilinear line equation here. So a naught is the constant, a1, a2, an are the slope, x1, x2, and xn are the different features in x. Okay. So when we get the equation like this, instead of mx plus c, we get it like this. Okay. V naught is nothing but the constant. So this is what we get. This is what we get. So applying the sigmoid function, we will get this equation. Then from here, we will get the probability of the equation. Then this, our equation will become this. So now if we apply this function here on this data, if we apply this function, so our data becomes something like this. So this is the data that we get after applying sigmoid function. So here, if we take the threshold value here 0.5, so below 0.5, all the values will be considered as 0, not obese, and above above 0.5, all the values will be considered as obese. Okay, I can change any. I can take any number of threshold. I can take any value for threshold between 0 and 1. So this is how our values get transformed. This is how our value get transformed. So basically what we did here, onto the linear regression line, we have just applied sigmoid function to convert it into logistic regression equation. So this is all about the theory of logistic regression. So we have simply applied sigmoid function onto the linear regression algorithm. After applying sigmoid function onto the linear regression algorithm, we get our data transformed like this. Okay, so this is what all about logistic regression theory. Now let us move on to
Yes.
the practical implementation.
Practical समझायला. हैं?
So for the practical implementation, I would request you all to please log into your respective cloud accounts. Yes, sure, I can explain it again, but that's all the part of mathematics. So here we have this equation y is equals to mx plus c. Here I am taking x, only one feature x. So I am taking an example of simple linear regression here. Okay, when we have only one input feature. Okay, if I have this one input feature, I will apply this function. This is the sigmoid function I will apply on it. Okay, so value of y is equals to mx plus c. When we apply log both sides, then we get the value like this. I have given the link to log into IBM Cloud account in the chat. I request you all to please log into IBM Cloud accounts. I would request the mentors to please share the data. I have shared the data in the chat. Also, the mentors have shared the data in the chat. So today we will be proceeding with a case study for loan approval prediction. So today we will be applying classification algorithms on loan approval prediction data. Ma'am, data set is shared in the chat and it will be shared on Telegram also. I request the mentors to please share the data on Telegram also. I hope all of you have the data set now. It is cloud.ibm.com. You can directly go to cloud.ibm.com. How to join Telegram group? Telegram group link will be shared in the chat by the mentor. Ma'am, data set is already shared. The data set is shared in the chat and on Telegram also. And the Telegram channel link has been shared in the chat. Please copy that link. Please click on that link and join the Telegram channel. So I request you all to please log into your IBM Cloud accounts and download the data set. So today we will be taking a classification problem in which we need to classify whether the loan will be approved or not. Classification problem simply refers to a predictive modeling problem where a class label is to be predicted for the given example of input. So here for this data set, we will be predicting for two classes if the loan will be approved or not. So here we will be having loan status as yes or no. So till the time you all get ready with your cloud account and the data set, let me explain about the data set. So I hope my Excel sheet is visible to you all. So Let us understand our problem statement first. So there is a company that deals in all kinds of home loans. So they have their presence all across the area, like urban areas also, rural areas also, and semi-urban areas also. So what happens in this loan application process? The customer first applies for home loan. After that, the company validates whether the customer is eligible for the loan or not. So here the company wants to automate the loan eligibility process. Okay, so the company has provided the detail and we have to build a model that is able to classify whether the customer is eligible for loan or not. So I hope the problem statement is clear. Now let us understand our data. So in my data, I have this loan ID. When we apply for loan, we get a unique loan ID. So this is that unique loan ID. Then we have gender of the applicant, male, female or other. Then we have married, yes or no. So in gender, we have two categories, male or female. In married, we have two categories, yes or no. Then we have dependent, number of dependents of applicant. So here we have some numeric value like 0, 1, 2, 3. Then we have education of the applicant. Then we have education of the applicant, whether the person is graduate or undergraduate. Self-employed or not. If the person is self-employed, then it is yes. If the person is not self-employed, then it is no. Applicant income. What is the income of the applicant who is applying for loan? What is the income of that person? Co-applicant is basically the co-applicant's income. Then we have loan amount. Then we have loan amount term. What is the term for loan? Then we have credit history. Then we have property area. The home loan for the property for which the person is taking home loan is rural, urban or semi-urban. Then we have target variable, that is loan status that we need to predict. If the person is eligible for loan, then it is yes. If the person is not eligible for loan, then it is no. Okay, so this is all about our data set. So I hope the data set is clear. So let us proceed with our today's problem statement. So for doing that, firstly, we need to go to resource list. Go to resource list. On the left right navigation bar, the second option is resource list. Here you can go and under services and software, you can find Watson Studio service. Under services and software, you can find Watson Studio service. So Miss Yoga Priya, ma'am, if you are facing issue with creating object storage and that issue is due to you do not have any resource group. So there is issue with your IBM account. You need to create a new IBM account for that. So for creating the new IBM account, Mahidar, our mentor, has provided you the request form so that you can request for a new SmartInternz ID and create a new account. So when you go to the resource list, after going to the resource list under services and software, you can find Watson Studio. You have to click on Watson Studio, then you will be landing onto this page. So how many of you are here on this page with me? So when we get routed on this page, we have to click on this launch in IBM Cloud Pack for data. We can simply just close this dialog box. Then again the same step that we have done last 2 days, we have to go to this menu. We have the menu option onto our extreme left top. We have this menu option here. The third option is project. When you click on project, under the project you will find view all projects. Under the projects you will find view all projects. Professor Arya Chandrapal, sir, the link is provided in the chat to request for SmartInternz ID. If you have your academic ID, so you can proceed with your academic ID, and the reference video is given in the chat by our mentor. So please follow that video for your reference. That reference video is to create IBM account. So you can follow that video. So here under the projects, we can see view all projects. So click on view all projects. The data set is shared on chat and in Telegram, ma'am. I'll share the data set again. Okay, the mentor has shared the data set again. Please download the data set from the chat. So here, when we click on view all projects, we will be landing onto this page. When we are on this page, we can see on our right hand side, we have an option for new project. So we have to click on new project. After clicking on new project, we will be landing onto this page. So here we have to select this first option, create an empty project. Uh, Ma'am, I have just shared the data set. Okay, I'm not able to share the data set. Ma'am, the mentor has just shared the data set in the chat. Please download it. It is loan underscore prediction.csv. So here, when we click on new project, we'll be landing onto this page. When we are on this page, here we have to give the name to our project. So I am giving day demo day 4. Okay. Then after giving the name, you can also give the description. As it is optional, I'm not giving it. So when you give the name, the create option on your right bottom will be enabled. Then you have to click on this create option. When you click on the create tab, your project will be creating and you'll be landing onto this page. Okay, so after creating the project, you land onto this page. Then here you have to go to the second option, assets. Then you go to assets, then we need to add the code editor notebook where we can code. So we have to click on new asset and go to this code editor. From the navigation bar, the fourth option, code editor, and then select Jupyter Notebook Editor, Jupyter Notebook Editor. And here we do not need to change anything here. We just need to give the name of our notebook. So I have given the name to the notebook. After giving the name, you can give the description also. I'm not giving any description here. Just click on create. Just click on create. For creating a notebook, when you will create a new project, you will landing onto a page where you can see your 4 options. The second option will be asset. Go to when you are on the when you click on the asset, you will get a blue colored tab named new asset. You have to click on the new asset. Then you have to select the code editor as Jupyter Notebook. When you select Jupyter Notebook code editor, you will be landing onto a new page where you have to give the name of your notebook, and on your right hand side bottom the create option will be enabled after giving the name, so you have to click on that. So here the very first step is to import necessary libraries. So what are the necessary libraries we need to import here? Am I audible now? Am I audible now? Okay. So here what we have to do after importing the necessary libraries, we just have to load the data set. So for loading the data set, we first have to upload the data set. So we can go to this option here on our right, on the white navigation bar. The last option is to upload the data. When we click on this option, we get this, and then we can simply drag and drop our data here. When the data is 100% uploaded, we will get the option to insert to code. So click here on insert to code and insert it as pandas data frame. We need to insert the data as pandas data frame. I hope we all have inserted the data set here in our code. So I am naming the data set as DF. I am naming the data set as DF, data frame. Okay. I am naming the data set as DF. Just change the name to DF here and execute it. Just change the name to DF here and execute it. Are we done till here? So after this, we need to understand our data. We need to understand about our data. So let us print the info of our data. So df dot info. So it is saying we have 614 entries. That means 614 rows from 0 to 613. Then it is saying that in total we have 13 columns. In total we have 13 columns. The first one is loan ID, then we have gender, then we have married, dependent, education, self-employed, applicant income, co-applicant income, loan amount term, credit history, property area, and loan state. And there are these many not null values in these respective columns. And the type of these respective column is this. I have shared the dataset in the chat, so you can download. Okay, so I am repeating this df.info again. So we have these 13 columns here: loan ID, gender, married, dependent, education, self-employed, applicant income, co-applicant income, loan amount. You want me to repeat from the very first step? So here we have just imported the necessary libraries: import numpy as np, import pandas as pd. After that, we have uploaded the data and then inserted the data. From here, we can just click on insert to code and insert it as pandas data frame. Then we have changed the name here to df and run the cell. After running this, we just run df.info. df.info. So I hope this data is clear. Now let us see the descriptive analysis of our data. So if you can see, the description will be given for only the numerical column. For the textual column, we will not get the description here. Okay, so this is the total count, mean, standard deviation, minimum value, maximum value, 25 percentile, 50 percentile, and 75 percentile value here. So done till here. Are we on the same step? Okay. So after this, we have to perform data preprocessing. For that, the first step is to handle missing values. Handle missing values. So to handle missing value, firstly, we have to check, do we have any null value? We have to first check that do we have any null value? So for loan ID, it is saying no null value. In gender, it is saying true. That means there is null value in gender. There is null value in marriage. Independent, there is null value. Education, there is no null value. Self-employed, there is null value. Applicant income, there is no null value. Co-applicant income, no null value. Loan amount, there is null value. Loan amount term, there is null value. Credit history, there is null value. Property area and loan status, no null value. Okay, so we have the null values. Now we need to know how many null values are there. If we need to know how many null values are there, so in gender there are 13 null value, married 3 null value, dependent 15 null value, self-employed 32 null value, loan amount 22 null value, loan amount term 14 null value, credit history 50 null value. Okay, so we have the null values. So now we need to treat the null values. So for treating the null values, first let us see what type of null values are there. First, let us see what type of null values are there. So here we are having null values in gender, married, dependent. Let us check the data for I hope my Excel sheet is visible. So in gender, we have null values. So gender have two categories, male and female. In married, we have null value. Married have two categories, no and yes. Independent, we have null value. So independent, we have 0, 1, 2, 3. Four categories, 0, 1, 2, 3. Then we have education. In education, do we have any null value? No, in education, we do not have any null value. Self-employed. Self-employed, we have null values. So in self-employed, we have two categories. So this is also categorical. This is also categorical. Applicant income, no null value. Co-applicant income, no null value. Loan amount. In loan amount, we have continuous value. In loan amount, we have continuous value. Okay. And in loan amount term also we have continuous values. We have continuous values. Null means there is no value for that column in that row. Okay. So out of which gender is categorical, married is categorical, dependent is categorical, self-employed is also categorical. Then we have loan amount as continuous. So these two here are continuous values. These two here are continuous values. So when we have null value, so how do we treat the null value? How do we treat the null value? We use statistical method to replace null value. Either we can drop all the null values. So I have some 600 rows. If I delete 50 records from here, so my data will become less. It can affect my data. So I am not deleting it from here. I'm not deleting it from here. What I am doing, I will replace them. I will simply replace the null values. I will simply replace the null values. So I can replace the null values using statistical method. I can replace the null value using statistical method. So what are the statistical method do we have? What are the statistical method do we have? We have many statistical methods, but for replacing we can use mean, mode and median. We use mean, mode and median. So whenever we have categorical values, then we use mode to replace the null value. That means we replace the null value of the categorical column with the most occurring value. Okay. Then if we have numerical values, so we can replace it with mean or median. Okay. So here we have some categorical value and some numerical values, right? So let us see how do we replace them. So we have df gender, we have df gender, we will use fill na function. Here. Fill na is used to fill the null values, as we have learned in pandas class. So fill na. I am filling the null values with the mode of the gender column. So I apply mode function, and here I am giving 0th index, comma, in place equals to true. For true, T is capital. Okay. So why I have given 0 here when it comes to mode? Why I have given 0 here? So my mode can be more than 1. Right? It is not necessary that we have only a single mode. We can have more than one mode also. That means there can be more than one classes occurring for the same number of time also. So giving 0 here means the first index is always taken of the mode. Okay. Now gender was categorical, so we have replaced it with me. So similarly, married is also categorical, so we will replace this also with mean. Why 0? Please repeat. Sure, I'll repeat once again why we are taking 0. Here I have some values in X. Girls, I have some values in X like girls, boys, boys equals women, men, boys, women, women, girls, girls. Okay, this is my data. This is the data I have. Can anyone please tell me the mode of this data? Can anyone please tell me the mode of this data? Okay, let me share the screen again. Is it visible now? I'm writing on a Word. I'm writing on a Word doc. It is visible. Is it visible now? So yeah, can anyone tell me what is the mode of this data? Girls is occurring for 1, 2, 3, and 4. 4 times girls, 3 times boys, 3 times women, and 1 time men. Okay, so the mode for this data is mode here becomes girl. Okay, mode here becomes girl. What if I have this data? What if I have this data? What if I have this data? This is in case 1. This is in case 1. In case 2, I have changed my data. Here I have added one more boy. So what will be the mode now? Mode for case 2 will be girls and boys. Girl and boys. So there will be two modes. There will be two modes. So mode with this zero index means the first value always. So even if we have a single mode, we will have the first value that is 0th index value. This is the 0th index. Even if we have two modes, so we will have 0th index value. So even if we have a single mode or more than one mode, we will always have 0th value. So if we have more than one mode, in that case, we are giving 0th index here. For that case, we are giving 0th index here. I hope I made it clear. Okay. And in is equals to true is given to make these changes permanent. In place is equals to true is given to make these changes permanent. So we were doing it for married. Married will also replace by mode as it is also categorical. Same with dependent. Dependents will also be replaced by mode as they have 4 categories 0, 1, 2, 3, 4. Now we have self-employed. Self-employed will be also replaced with mode as it is also categorical. So when we have categorical data, we replace it with most occurring class, that is mode of that column. Then we have loan amount. So in loan amount, we have continuous values and in small range. In loan amount, we have continuous values in small range, right? When we have continuous value in small range, we will replace it with mean. We will replace it with mean. So we have continuous values here for loan amount. So I am replacing it with mean. I am replacing it with mean. And similarly for loan term. Similarly for loan term, we will replace it with mean. Now let us come to loan history. Let us come to loan history. Now let us check the type of data in loan history. Let us check the type of data in loan history. Let us check the type of data in loan history. What type of data is there in loan history? So we have categories here 0, 1, 0, 1. That is yes or no. If the person is having any loan history or not. Okay. So two categories here. Yes or no. So this is also categorical. So tell me, what should I replace it with? What should I replace it with? Mode. I should replace it with mode. Right. Dependent is numerical, but let me show this. For dependent, if I check the unique values, what are the unique values for dependent? 0, 1, 2, and 3 and 9. So 0, 1, 2, 3. Only these four categories, these four numbers are repeating. These four numbers are repeating. If I take the mean of these numbers, then the value will be out of the range of these four, right? So that is why I have taken the mode here. I hope it is clear now. Sorry, it is not loan status, it is loan history. Sorry. It is loan history. I have copied wrong by mistake. Median is taken in the case of very high values when we have. For example, if we have the value of salary, so salary of a person can range from 1,000 to any infinite, like any number in lakhs, in crores, in billions, in trillions. Okay. So when we have very high range of numerical values, then we take median. And when we have small range of numerical values, like we have age. So age can range till 150 only, the maximum I am taking. So When we have these small ranges of numerical value, then we replace it with mean. And when we have very high ranges, then we replace it with median. I hope I made it clear. So let us execute it. So now we have replaced all the null values. Now let us check if there is any null value in our data. Df dot is null dot any. So here you can see now there is no null value. So we have treated all the null values. We have treated all the null values. So now we will move on to the next part, that is handling textual data. Handling textual data. So how many textual column do we have? How many textual column do we have? This one, gender, married, yes, this is also textual. Education is also textual. Then we have this also textual and this also textual. So we have 1, 2, 3, 4, 5 and 6. 6 textual column. Why I am not taking loan ID in count? So let me explain why I am not taking loan ID in count. So let us take an example of a college student. If the college student is having roll number 15, will it make any effect on the performance of the student? For example, if I am predicting the performance of the student, I am predicting whether the student will pass or fail. So is loan ID, will roll number make any difference on the student performance? Is it something like roll number 1 will always pass and last roll number will always fail? No. So the unique ID, that is here, the unique ID is loan ID. These unique ID will not make any effect on the prediction, are not making any effect on the loan status. So whether the loan ID is 1002, it is not affecting the output. Whether the ID is this, it is not affecting the output. So that is why we do not take unique ID into the count. Okay. So that is why I'm not counting it. So the textual column we have is 1, 2, 3, 4, 5, 5 and 6. So we have 6 textual columns. Let us treat these 6 textual columns. Okay. So firstly we have to convert textual columns okay. This is done using label encoding as we have done yesterday. So instead of using these encoding techniques, you can use other methods also. You can use get dummies method also. You can use mapping and replace method also. Okay. So here I am using label encoding method. So for that, firstly, we have to import the library for label encoding from sklearn.preprocessing. Import label encoder. Creating an instance for label encoder. Okay. After creating this instance for label encoder, what we have to do, we have to fit and transform our data. So firstly, we have to fit and transform this df gender so df gender is equals to le dot fit underscore transform of df gender. Okay. Similarly, we can do this for other categorical columns also. So we have married, we have married, then we have education, then we have education, then we have self-employed, then we have property area, then we have the last column, that is loan status. Okay. So I am copying and pasting it in the chat. So now I am executing it. Okay. Now let us check our data whether it got converted or not. Yes, you can see now there is no textual column. There is no textual column now. Okay. Now let us split our data into dependent and independent variables. Split into dependent and independent No, ma'am, these changes will not be reflected onto your CSV file, but the data set that you have loaded here, the data frame, this DF, on this data frame, these changes will be reflected. So here in X, I want all these columns: get gender, married, dependent, education, self-employed, applicant income, co-applicant income, loan amount term, credit history, and property area. I just don't need this loan ID and loan status, because loan status is anyhow the target variable. So what I will do here in X, I will keep all the values of DF, just I will drop these two columns. Okay, so DF dot drop columns. What columns I need to drop? The first one is loan ID. The second one is loan status. Okay. And then I have to convert it into the values. Now let me check the values of X. So you can see now it is converted to values, that is NP array here, and we have dropped these. Let us check the shape of X. Previously, the shape of DF was 13. It had 13 columns. Now let us check the shape of X. Sorry, it is not couple. So now we have 11 column because we have dropped loan ID and loan status. Now we have split it X, and now we want to split Y. So in Y we want from DF, we only want one column, that is loan status. That is loan status. Dot values. Okay. Now let us check the values of Y. So these are the values in Y. Let us check the shape of Y. It will be having only one, it will be having only one column. Now what we need to do? Now, when we have performed this label encoding, in gender there were two categories. I am putting comments here. In gender there were two categories, male and female. So it will be converted to 0 and 1. What are zeros and ones in the term of machines? Zeros and ones are binaries. Zeros and ones are binaries. Binaries that are considered themselves, those are considered two different classes. Zero is one class, one is another class. Similarly, in married also we had only two classes, yes or no. So it is also converted to binary, yes or no. In education, we had graduated or undergraduated. Graduated, or I'm writing short form, undergraduated. Then we had in self-employed, we had yes or no. In property area, we had three classes: urban, rural, and semi-rural, semi-urban. Yes, semi-urban. So we have urban, rural, and semi-urban. And in loan status, we had two categories, yes or no. Okay, so yes or no. So when we have only two categories, those are converted to zeros and ones. Zeros and ones are itself two different classes. So do we need to apply one hot encoding to zeros and ones? Do we need to apply one hot encoding to zeros and ones? No, we do not apply. We do not need to apply any one hot encoding to binaries. But in case of property area, we have three categories. So it will be converted to 0, 1 and 2 in alphabetical order, right? So here we need to apply one hot encoding. Here we need to apply one hot encoding. So let us apply one hot encoding here. So for applying one hot encoding, firstly let us import from sklearn dot preprocessing import one hot encoder. Create the instance for one hot encoder. Then I am creating a new variable for one hot encoder, that is Z. One dot fit underscore transform. I want to
without getting into the complex, doing complex calculation, without doing all the research by yourself. How much should they?
So here I need to transform only one column, that is this column, property area, right? So in X I have these values starting from gender 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 11 columns 0 to 10 we have in X, right? So I need to transform only this 10th column. I need to transform only this 10th column, right? So let us transform this 10th column. So from X, I need to transform all the rows of the column 10. Okay, and convert it to array. After that, so these are the three columns that we get after converting, after applying one hot encoding on property area column. Now what we need to do, we need to delete property area from our data set. So from X we need to delete the column from X 10 and axis shows the column. Okay, and after deleting it, we need to concatenate Z. We need to concatenate np dot concatenate Z with X along the axis 1, that is along the column. Okay, so the shape of X was 11. I have dropped one column, that is property area. This becomes 10. This becomes 10. After that, I have added 3 columns. I have concatenated 3 columns of Z with 10 columns of X. So it became 13. So it became 13. So let us check after apply one hot encoding, how many columns are we getting? X dot fit. So we are getting 13 columns. That means our one hot encoding was applied successfully. Okay. So we have applied one hot encoding successfully. Now we need to train, test and split our data. Now we need to train, test and split our data from sklearn dot model underscore selection import train underscore test underscore split, creating 4 variables x underscore train comma x underscore test comma y underscore train comma y underscore test. Okay, I have splitted my data into 80-20 ratio. So 80% will be for training and 20% will be for testing. Okay, so let us check the shape of X train. So 491. So 80% of 614 is 491. And in X test we have these many columns, rows, 123. Okay, so 80% in training and 20% in testing. Now we have a step in classification algorithm that we say scaling of the data. So I have explained in the beginning of the session why do we scale the data. So we scale the data to make it, to scale it to a range. Okay, so before scaling the data, if you want to see the data, so this is the value in X. These are the values in X. After scaling, now let us scale and see what will be the values. So from sklearn dot preprocessing import standard scaling, creating the instance for standard scaling and fitting our inputs to scale. Sorry, it is standard scaler, not scaling. It is standard scaler. So I have missed this brackets here. So after putting these brackets, I'm not getting the error. So for now we are done with our data preprocessing part. After performing data preprocessing, what is our next step? We need to perform model building. We need to perform model building. So building the model, we are building logistic regression model. As I have already told you, it is a type of linear model. So we will use the same class from sklearn.linear model. We will just import logistic regression, and then we will create the instance for this. We will create the instance, and then we will fit our data. We will fit our data to this logistic regression. So we have to fit our training data. Okay. Now the turn is to test our model. Now we need to test our model. So I am taking a variable log thread that is predicted by for logistic regression, and I will use the same function, predict function, log predict to predict the value of y. Okay, so these are the values that I am getting. These are the values that I am getting. Now let us compare it with original y test values. So you can see some differences in the values. You can see some differences in the values. So now let us check the accuracy score for this. So similar, as we have some evaluation metrics in regression, similarly here for this classification or algorithms, we have different evaluation metrics. Okay, so we have accuracy score here, we have confusion metric, we have ROC AUC curve. So let us begin with the evaluating performance of our model. sklearn dot metric import accuracy underscore score. Accuracy of logistic regression will be the using this accuracy score for log spread and y test. And then I am printing the accuracy. So here you can see the accuracy of this model is 83.73. Okay, so our model is the accuracy of our model is 83.73. So now we have another evaluation matrix here that is very important evaluation matrix, that is confusion matrix. I will explain about these evaluation metrics in few minutes. So let us first brush up with, let us first learn about all the algorithms that we have to do today. So here we have built the model using logistic regression. Here we have built the model using logistic regression. For regression, R2 score is used, and for classification algorithms, we use accuracy score, confusion matrix, ROC, AUC curve. (32) In cell number 32, it's just y test. I've written nothing here. So we are done with our model building using logistic regression here. So let us move ahead as we are running out of time. We have a lot to cover. Okay. So about the evaluation metrics, I'll explain them. Just please let me cover the algorithms first because we have a lot of content to cover. So let us move ahead to the next algorithm, that is decision tree algorithm. We have the next algorithm with us, that is decision tree algorithm. Let us move ahead with decision tree algorithm. So what is decision tree algorithm? As the name suggests here, it is a kind of tree structure that we have. Here in this algorithm, we will have a kind of tree structure. Okay. So here you can see an example. Suppose I'm going to buy a phone. There are some criteria on which I will buy the phone or not buy the phone. So if the screen size is greater than 5.9 inches, this is the first condition. If this condition is true, I will check for other condition. If this condition is not true, I will not buy that phone. If the screen size is greater than 5.9 inches, then I will move on to the second condition. That is camera. Camera must be greater than 14 megapixels. Camera must be greater than 14 megapixels. So if camera is greater than 14 megapixels, then I will check for next feature. Otherwise, I won't buy it. Then if the processor is more than 12 gigahertz, then I will, and quad core processor we have, then I will buy it. Otherwise, I will not buy it. So this is an example for is my screen not shared? Can you see the presentation now? So this is the example that I have just explained. Here I have three criteria: screen size, camera, and processor. If the size of the screen is greater than 5.9 inches, then I will check for other feature. Otherwise, I will not buy the phone. If the size is greater than 5.9 inches, then I will check for the second condition, the camera. If it is satisfying this condition, that I will check the next feature. Otherwise, I will not buy it. If the processor is more than this given condition, then I will buy it. Otherwise, I will not buy it. So this is what happens in decision tree. So here decision tree builds regression and classification. So let me tell you, decision tree is used for both classification and regression, both. And what does it do? It simply breaks down the data set into smaller and smaller subsets, and with every subset there is a decision associated. With every subset there is a decision associated. So if you see here, I have splitted my data, and at every point, at every step, there I am making a decision. If this is yes, then go and check for second step. If this is not the case, then we have the decision, do not buy it. Okay, so with every node there is a decision associated. So this is what decision tree is. And the final result of the decision tree with decision nodes and leaf nodes. So the final result of the decision tree will be a tree structure with leaf nodes and decision nodes. Okay. So let us understand this with an example. So here I have this example that is having 14 rows, and it is having three input features and one is output feature. So based on outlook, humidity, and wind, we will decide whether the child can go out to play or not. Okay, if the weather is sunny, humidity is high, wind is weak, then the child cannot go out to play. If the weather is sunny, if the outlook is sunny, humidity is high, wind is strong, then the child cannot go out to play. All the red ones are for no, all the black ones are for yes. So we have 9 yes training example and 5 no training example. So in this data set, we have 3 different values for outlook, sunny, overcast, and rain. We have 2 different value in humid, that is high and normal. We have 2 different values in wind, that is weak or strong. Okay, so based on these 3 factors, we are deciding whether the child can go out to play or not. Okay, so I hope this example is clear, this data is clear. I hope this data is clear. Okay. So here, now if we want to predict that on day 15, the outlook is rainy, the humidity is high and the wind is weak, whether the child can go out to play or not, how do we decide it? Let us see this problem with the help of a decision tree algorithm. So we will divide our data on outlook. So we have three different values for outlook: sunny, overcast, and rain. Sunny, overcast, and rain. Okay. If the value of, we have these sets for overcast. In overcast, if the overcast, if the outlook is overcast, no matter what the wind and humidity are, the child can go out to play. You can see the example here. You can see the data. Overcast, child can go out. Overcast, child can go out. No matter what the combination is with humidity and wind. Okay. Sunny, overcast, child can go out. Overcast, child can go out. So if the outlook is overcast, child can
ಲ್ಯಾಪ್ಟಾಪ್
go out.
ಸ್ನೇಹ ಇರ್ಲಿಲ್ಲ ಅಂತಿದ್ರೆ ಇವತ್ತು ಸೆಷನ್ ಗಾನ್. ಇವಳು ಹೇಳಿ
I request all to please mute yourself. So whatever is the value for humid and wind, if the outlook is overcast, the child can always go out to play. Okay. In case of sunny, in case of outlook is sunny, if the wind is high, no matter if the humidity is high, no matter whether the wind is weak or strong, the child cannot go out to play. But if the humidity is normal on sunny day, the child can go out no matter what the wind is, whether the wind is weak or strong. Okay, the child can go out if the humidity is normal. If the humidity is high, whatever the value of wind is, the child cannot go out. And in the case of rain, rain is, if the outlook is rain, humidity is high, and wind is weak, child can go out. If it is raining, humidity is normal, wind is weak, child can go out. So high or normal, humidity high or normal, not making any effect. It is depending on wind here. So if outlook is rainy and wind is weak, child can go out. If outlook is rainy, wind is strong, child can not go out to play. Okay. So now I have told you that we will divide the data set into smaller subsets. Until when we need to divide the data set and when we do not need to divide the data set. How do we decide that? Now comes in the picture is the pure set and impure set. Pure set is nothing when we have all yes or all no. When we have all positive or all negative, then it is said to be a pure set. And if we have mixture of yeses and nos, if we have mixture of positives and negatives, then it is said to be impure set. So when we have got a pure set, then we will not divide it further. We can only divide impure set. We will not divide pure set. So here in overcast, all the values are positive. So do we need to divide it further? No, because it is a pure set. We do not need to divide it further because it is a pure set. But in case of sunny and rain, we have mixed set. That is, we have impure set. So do we need to divide sunny and rain? Yes, we need to divide sunny and rain because here we have 2 yes and 3 no, and in rain we have 3 yes and 2 no. So this is
9:30
how
ವರೆಗೂ
we will
ಸೆಷನ್ ಇದೆ.
divide.
ಚಾರ್ಜ್ ಆಗೋಗಿ ಲ್ಯಾಪ್ಟಾಪ್ ಆಫ್ ಆಯ್ತು, ಮೊಬೈಲ್ ಅಲ್ಲಿ ಲಾಗಿನ್ ಆಗಿ.
I'm requesting the participants who are joining the meet again. So please be on mute. Okay. So if the outlook is sunny, so it was depending on humidity. If the humidity is high, then the child cannot go out. If the humidity is normal, then the child can go out. If the outlook is rainy, then it is depending on wind. If the wind is weak, then the child can go out. If the wind is strong, then the child cannot go out to play. Okay, so this is what we get after splitting sunny on the base of humidity and rain on the basis of wind. So now, what type of set we have here? Is it a pure set or impure set? We have a pure set here. So we do not need to divide it. Here also we have a pure set, so we do not need to divide it. So here also we have pure set, pure set, pure set. So we do not need to divide them any further, right? So we are on our decision here. So we are on our decision here. So we have got our decision tree ready. So we have got our decision tree ready. How? We will see that. If the outlook is overcast, child can go out. Child can if the outlook is overcast, yes, the child can go out to play no matter what is the value of rain and what is the value of wind. If the outlook is sunny, then we will check for humidity. If the humidity is high, child cannot go out. If the humidity is low, child can go out. If it is raining and wind is weak, child can go out, and wind is strong, child cannot go out to play. Okay. So now we had an example, right? What is that example? So we have to tell for rain, high and weak. When the outlook is raining, humidity is high and the wind is weak, yes, the child can go out to play. Yes, the child can go out to play. Now I am giving you one example. If the outlook is sunny, and humidity is normal, and wind is strong, can the child go out to play? Can the child go out to play? Yes. How? Outlook is sunny, then humidity is normal. Then no matter how the wind is, child can go out to play. Okay. So this is how it works. This is how it works. So now, why do we split this data on Outlook? Oh, why do we split this data on Outlook? We could have split it on humidity, or we could have split it on wind. So how do we decide this? How do we decide this? If we have split on Outlook, we got these values. If we split on wind, we got these values, right? So why couldn't we split on? Why couldn't we split it on wind? Here comes into the picture in information gain and entropy. Here comes into the picture information gain and entropy. So now let us first see what is entropy. Entropy, in the most layman language, if we say, in the layman terms, we say entropy is nothing but the measure of disorderness, measure of impurity. That means how impure my set is, how impure my set is. Okay, so it is the measure of randomness, or it is the measure of disorderness of the data. Okay, so the mathematical formula is as follows: minus of p plus log p plus minus p log p. P plus is nothing but the positive values, all the yeses. All the yeses are p plus, and p is nothing but the negative values, all the no. Okay, so this is the formula: minus of p plus, that is probability of all yes values, log p plus, and probability of all no values, log probability of all no values. Okay, so here we have the formula as minus p plus log p plus minus p log p, and log to the base 2. So here S is nothing but the sample, that is training data set. P plus is the proportion of positive examples, and P is the proportion of negative examples. So let us first check the entropy if we split it on, if we split our data on this. If we split our data on Outlook, then we get this. I'll show you the graph. Okay, so this is what the graph, the tree is. In case of Outlook, we have 9 positive values and 5 negative values. Okay, so out of total 14, total training examples are 14, out of which 9 are yes, 9 are yes, and 5 are, sorry, 5 are no. So how do we calculate P plus? P plus is how many are positive out of total. So 9 out of 14 are positive, and value of P will be how many are negative examples out of total examples. So 5 out of 14 are negative examples. 5 out of 14. Okay, so here you can see minus P yes, that is this P plus 9 by 14 log 9 by 14, and 5 by 14 by 5 by 14 for तीनों. Okay, so this is what entropy when we, this is the entropy when we split on outlook. This is the entropy when we split on outlook. This is the entropy when we split on outlook. Okay, understood? Entropy understood? I hope I have made it clear. The mathematics behind entropy is understood or not? Now we have calculated the entropy in case of when we take our root node as outlook. Okay. So now what is information gain? What is information gain? Information gain can reduce the entropy caused by partitioning, and information gain can reduce the entropy that is caused by partitioning. That is, information gain is the expected reduction in the entropy caused by the partitioning of the example with respect to an attribute. So the entropy of my data is this. Okay, entropy of my data was 0.939 when I split it on outlook. Okay, so now if I split it, so information gain is the expected reduction that is caused by partitioning with respect to the examples. Okay, now what is information gain? Let us understand in mathematical way what is information gain. Log 2 is log base 2. Log 2 is nothing but log base 2. So we have different base for log. So here we are using log with base 2. So here information gain for sample S. S is nothing but the example we have, data set we have. The attribute on which we are splitting our data. A is the attribute on which we are splitting our data. Okay. Entropy is the entropy that we have just calculated 0.939, and here we will calculate the new entropy in the terms of the partitioning. Okay, so basically if we say, so it is the current entropy minus new entropy. So what we need to calculate? We need to calculate this new entropy. So let us see how do we calculate this new entropy. So current entropy is this much. Okay, if we are splitting on wind, if we are splitting our data on wind, that is here you can see, if we are splitting our data on wind, first we are casing that we are taking the case when we split our data on wind. If we split our data on wind, then what happens? Here we have two categories, weak and strong. In wind, we have two categories. So our sample S and A is the attribute wind here because we are splitting it on wind. Okay. So firstly, we will calculate the entropy for weak and strong. We will calculate the entropy for weak and strong. So S weak by S. S weak by S is number of observation for week and total number of observation. So number of observation in week 6 plus 2. Total observation in week are 8 and total observation of the sample S are 14. So 8 by 14. Okay. Now entropy formula. Now we have the formula for entropy. So what is the formula for entropy? Say minus of P plus log P plus P plus. Okay. Minus P log P. P log P. Okay. So this is the formula. Okay. So here we have S week, observation in S week by total observation in the sample with the entropy of S week. So let us go to this week. In week we have 6 yes and 2 no. Out of 8, how many samples do we have in yes? We have 6 samples out of 8 in yes. And in no we have, for no we have 2 samples out of 8. In the case of week, okay. So here you can see P plus 6 by 8 log 6 by 8, 2 by 8 log 2 by 8. Okay. This becomes 8 by 14 into 0.811. Here, after doing the calculation of these logs, we get these value here. Okay. Similarly, we will go for strong. The observations in for strong are 6, 3 plus 3, 6 out of total observation 14. 3 are positive and 3 are negative. 3 are positive and 3 are negative. So here this entropy becomes 1 and this value is multiplied with. Okay. Understood? Is this part understood? If we split our data on wind, then this will be our information gain. Is this part understood? The mathematics is understood? I hope I made it clear. Now, what was the formula of entropy? Or current entropy minus new entropy. So the current entropy was this. New entropy is the summation of both of these. Okay. So here we get the entropy as 0.048. Information gain as 0.048. Here we get the information gain as 0.048. This was the case if we split it on wind. This was the case if we split it on wind. It is the formula, sir. It is in the formula. I have not made that formula. That is the formula for entropy, sir. So now let us take the second case, outlook. Let us take the second case when we split it on outlook. So in outlook we have 3 sunny, overcast and rain. There are 5 observations in sunny out of total 15, 2 positive and 3 negative. And this will be the value. In the case of overcast, we have 4 positive and 0 negative. So 4 positive and 0 negative. So this will become, after multiplication, this will become 0. And in case of rain, total 5 observation out of 14, out of which 3 are positive and 2 are negative. This is clear. I hope this is clear. Okay. So now let us calculate information gain in the case of outlook. For the second case, outlook, let us take the information gain. So here my current entropy is 0.939 and this becomes, when I subtract the sum of the new entropy, it becomes 0.247. So what you say? Which information gain is better? 0.048 or 0.247? Hello, I hope I'm clearly audible. I hope I'm clearly audible. So when we split our data on wind, we are getting information gain of 0.048, and when we are splitting our data on outlook, we are getting information gain as 0.247. 0.247. So obviously the information gain in case of outlook is better. In case of outlook is better. So that is why we have splitted our data on outlook. Understood? So this is how we decide the root node. Root node is the node on which we have to split our data on. Okay. Root node is the node on which we decide to split our data on. Okay. So this is all about decision tree theory. Now let us move on to the practical implementation of this decision tree regression. Monthly limit. Yes, just please give me a minute. There is some issue with IBM account. Let me. Hello all. So for my account, the monthly limit has exhausted. The CUS have exhausted. So I am downloading. I have downloaded the notebook that I have just done. So I will be continuing in another account. So I think some of you also facing the same issue. Uh, yes. So our technical team will help you out in this. After the session, we will provide you the solution. So those who are facing this issue, I would request you all to please be on the session. Please listen to the session, understand the concept, and we will try to resolve this issue. For now, I am continuing with another account. So for now, I will be continuing with another account. I would request you all to please be on the session. Those who are facing this issue, we will resolve it out. So those who are not facing this issue can use the same notebook. So I have downloaded the same notebook. So I am going to Watson Studio and creating a new project because I have to explain it. I am creating a new account. I'm creating a new project here. So here you can see I am able to create a new project. So I'm clicking on this new project. And here I will tell you how to upload a notebook because I have done the part. I have done logistic regression. I will be using the same notebook here. Okay. So I am naming it as demo day 4. I'll go to the assets. Create new notebook, new code editor notebook, Jupyter editor. Now here I have downloaded the notebook that I have done in the previous account. So I will upload that notebook here. I will upload that notebook here because I want to continue in the same notebook. I will go to from file. If you need to upload any notebook here, so what you have to do, you just have to go to from file and upload the file here, and then the name will be auto populated and you just have to click on create. So here I'm loading the data set till my notebook is loading because I have created a new project. So I have to execute from the beginning now. Yes, the same data set, the same notebook we are going to use for the same use case. We are going to apply the new algorithm. So for the same use case, we will be applying the 3 algorithms that we are going to do today. It's just taking time to load. If you create a new asset, ma'am, then you have to do all this data pre-processing and prior steps again. So I would request you all to continue in the same notebook. Then it is fine. Okay, so the notebook is loaded. I will have to run the code from the beginning. So the kernel is starting. We have to kernel this is connected to the kernel. Okay, so you can see the data is executed. Let me execute all the cells again. Okay, so now we need to build the model with decision tree classifier. Okay, so for building the model with decision tree classifier, we need to import decision tree classifier. We need to import decision tree classifier. So from sklearn dot tree, from sklearn dot tree import decision tree classifier. Okay, then the same step, create the instance. Now here we have to give the criteria. Here we have to give the criteria of splitting the data. So here we are taking the criteria as entropy. Then just fit our training data to this. So x underscore train, comma y underscore train. DTC dot fit x underscore train, comma y underscore train. Okay, let us execute it. I am pasting this code in the chat so that you guys can copy from the chat. So I have given in the chat. Now our model is built. Now let us test our model. So I am creating a variable DTC pred and DTC dot predict on x underscore test. Let us check DTC pred. This code also I'm giving in chat. So now these are the predicted values I am getting. Now let us evaluate the performance of our model. Let us evaluate the performance of our model. So we have already imported these libraries for accuracy score and for confusion matrix. So we do not need to again import them. So we can just simply use DTC accuracy is equals to accuracy underscore score for accuracy score for DTC pred and original by test values. Print this. So the accuracy we are getting is 65%. So we are getting very less accuracy. Okay. Now let us check the confusion matrix for this also. Let us check the confusion matrix. So CM DTC CM. So this is the confusion matrix we are getting. So let us see our last algorithm for today, that is random forest regression, that is our random forest classification. So random forest. So random forest is the implementation of number of decision trees. Okay. So what happens is random forest is, here we have a single decision tree and a decision is made by this decision tree. Here in random forest, we will have n Sorry. Hello. Sorry, I just got. Hello. Sorry, I just got audible, and the presentation is also visible. I hope I'm clearly audible and the presentation is also visible. Sorry for the inconvenience. I just got disconnected. So let us see this last algorithm for today. So we have this random forest. So random forest is the implementation of multiple decision trees. Okay. So here what happens with in random forest is we have this single decision tree and a decision is associated with this in this tree. Okay. So in random forest, we will have n number of these trees. And with every tree, a decision will be associated. So what will be the final resultant of random forest algorithm? The final resultant of the random forest algorithm will be the output, the the majority of the output of each decision tree. That is, the majority of the output getting from each decision tree will be the output of random forest classification. So for example, if we have data set with 1000 number of rows and 30 columns, okay, so we are splitting our data row wise. If we are splitting our data row wise, 100 rows, 100 rows, 100 rows, 100 rows. So then we will be having 10 decision trees, 10 different decision trees. So 10 into 100 is 1000. So we will be having 10 different decision trees. And if we are splitting it on the basis of columns, so we have three different columns. So if we split it three columns, three columns, three columns, so we have 10 different sets here. Okay, so we can split our data row wise or column wise, and we can build n number of decision trees. For example, this is my data set. I split it into three parts, and for have a decision tree here. Okay, so what will be the output? So for example, this gave me yes. This tree gave me the output as yes. This tree gave me the output as yes, and this tree gave me the output as no. Okay, this tree gave me the output as no. So what will be the output? The output will be the majority of the output. So the output here will be yes. Output here will be a yes. The majority of the outputs from the decision tree. Okay, so this is how random forest works. This is how random forest works. So the resultant is taken as the majority of the outputs from the decision tree. So we simply say that random forest is the application of multiple decision trees. Here we implement multiple decision trees. So let us move ahead. Is my IBM notebook visible? Is my IBM notebook visible? Am I clearly audible? Okay. So if it is visible, now let us build our model with random forest classifier. So let us build our model with so we have to import the library first from sklearn dot ensemble. Import random forest classifier. Okay, then again we will create an instance for random forest classifier. And here we have to give the criteria as entropy. Okay, and then fit our data, fit our training data to the model. I am giving this code in the chat so that you all can use the code. So let the cell execute. Okay, so it has executed. So now let us predict the values for the access input. So RFC dot predict and give the input as access and print this RFC value. Okay. After this, what we have to do, we have to evaluate the performance of our model. So for evaluating the performance of our model, we have to check the accuracy. So RFC accuracy is equals to accuracy underscore score of y test comma RFC thread and print RFC accuracy. So the accuracy here you got is 76%. Okay. Now let us check the confusion matrix. Let us check the confusion matrix. So RFC confusion matrix is equals to confusion underscore matrix. Again y test comma RFC thread. So we have built our model with three algorithms, that is decision tree, random forest, and logistic regression. Ma'am, I'll send the whole code in the Telegram group. let us move on to the last topic for today's session. Already 10 minutes are up, but I have to tell this. I have to continue with evaluation metrics. Just we will do evaluation metrics and finish it for today. So we have some evaluation metrics. The first one is accuracy score. So accuracy score is the number of predictions, number of correct prediction on total number of predictions. Okay. So out of total prediction it makes, how many were the correct predictions? So this is what accuracy score. Accuracy score is simply what how many correct predictions were made by the model. Okay. Then we have confusion metrics. So I have told you confusion metrics is very important. Confusion metrics is very important. So here we have given the example. So here if you see, I hope my PPT is visible. Okay. So here we have this confusion matrix here, example for confusion matrix here. Okay. So if you have seen here in the practical implementation, this is how my confusion matrix is. This is how my confusion matrix is, right? So this is nothing but true positive, false negative, false positive, true negative. Okay. So let me show you here itself. True positive, true negative, false positive, and false negative. So here, out of total predictions, 17 were positive and also predicted truly as positive. So 17 were positive and predicted as and also predicted as positive. For example, these 17 were true and those are predicted as true. Okay, that means these were yes. For these 17% loan can be, they are eligible for the loan and it was predicted as right prediction. Like it was predicted that for these 17%, the loan will be approved. So these are 17 true predictions that are made correctly. For 77 predictions, 77 true negative. These were negative, like for these original value were no and also predicted value was also no. So these 77 were correctly predicted as false. These 77 were correctly predicted as negative values, as false values, and false negative. These values were originally true but are predicted as negative, and false positive means these values were originally negative. These were no but predicted wrongly as true. 13 values were originally no but predicted as true, and 14 values were originally positive, were originally yes and predicted as no. Okay. So this is what confusion matrix is. This is what confusion matrix is. This is what is confusion matrix. I hope you understood this. Then we have ROC AUC curve. Then we have ROC AUC curve. So AUC is area under the curve. ROC indicates receiver operative curve. So ROC AUC curve is a performance measurement of classification problem at various threshold settings. So at different threshold values, it tells us the performance of the model. Okay. So if the value of the ROC is, if the value of the AUC is 1, that means all the true negative are predicted as true, all the true positive are predicted as true negative are predicted as negative, and the true positive are predicted as positive. All the predictions were made correctly. So this is the ideal condition. This is the ideal condition. That means our model is 100% accurate. But this is not a real case scenario. This is not a real case scenario because no model can be 100% accurate. Either it can be overfit but not 100% accurate. Okay. Now we have a perfect distribution plot where the AUC will be 0. AUC, if the AUC is 0.7 or above, then it is said to be a perfect distribution. That means 0.7 true negative percent values were predicted as true negative, 0.7 true positive values were predicted as true positive. That means above than 70% values were predicted as were predicted correctly. Okay. Then we have this. Then we have this where 50% values are correctly predicted, 50% corrected values are negatively predicted. So this is the worst model we can say, where 50% values that were originally true but predicted as negative, 50% values that were originally negative were predicted as true. So this is the worst case scenario we have in ROC AUC curve. Okay. So when it comes to confusion matrix, we can derive many other metrics from confusion matrix. That means TPR. TPR is nothing but true positive rate. TPR or recall or sensitivity. It is true positive rate. That means how much true positive value were predicted, how much positive value were predicted correctly. Okay. So this is also called recall and sensitivity, and formula for this is true positive upon true positive plus false negative. That can be derived from here. Okay. Now we have specificity. So this is sensitivity and now we have specificity. Specificity is true negative upon false positive. How many negative values were correctly predicted as negative? Okay. Then we have false positive rate. This is true positive rate. This we have false positive rate. False positive rate formula we have FP upon TN plus FP, or we can simply subtract specificity from 1 to get FPR. So these are some important derivatives of confusion matrix. AUC, full form of AUC is the full form that we use in mathematics, that is area under the curve, and ROC is receiver operator characteristic. Okay. AUC is area under the curve, ROC is receiver operating characteristic or we also call ROC as probability curve. It is also called as probability curve. So that's it for today. So our topic is still pending, that is introduction to unsupervised learning. So anyhow, the time is over. So thank you all for being a great audience. I hope the session was useful for you all. So thank you all. If we have any queries, so we can have. If you have any queries, so we can have it. Receiver operating characteristics. Tomorrow there is no session. On Sundays we do not have any session. Sir, I am a machine learning engineer working in SmartBridge. Yeah, that CUH exhausting limit, we will address the issue on Telegram group, sir. Sure, Miss Yoga Priya, we will share it, ma'am. We will share it as soon as it is possible. No, we do not have any session on Sundays. To scale our data, so basically we need to scale our inputs also, right? Whenever we are taking inputs to predict, we need to scale them also. So that is why we have scaled excess also. Thank you all. If we do not have any queries, so we will end the session.